Okay, so question 47. Give the configurations of the products obtained from the following reactions. This is actually not too terrible of a question. I'm just going to do sub-question A. And so basically what we have, again, this is all chapter all about alkynes, so not surprisingly we have an alkyne, an internal alkyne for our reaction. So we have two different reactions going on. The first is the dissolving metal reduction, so sodium metal and then liquid ammonia. And then the second is we have not H2 gas, but D2 gas. Okay, so just remember that deuterium, or D, is just a heavy hydrogen. That's all it is. It's a heavy hydrogen. Has the same type of reactivity for all intents and purposes for what we're concerned with. Okay, and we have our palladium on carbon, which is going to catalyze basically another reduction. Okay, so let's break it up. First question, or first bit, is the dissolving metal reduction. So here you have to remember that you have two different possibilities, cis or trans addition. And so for the dissolving metal, we have a trans configuration for the final product. So we're going to have 1, 2, 3, 4, 5, 6 total carbons. 1, 2, 3. So that's going to be 1, 2, 3 right here, 4 right here, 1, 2, 3 right here, 4 right here, and we're going to have a double bond. Okay, because remember, we're going to have just a single reduction, not a double. If we were doing this with D2 and palladium on carbon to begin with, that would be a complete reduction. But here, we're only doing a partial reduction to an alkene. Okay, so and again, you have to remember that the final hydrogen addition is going to be in a trans manner. Okay, so this is going to end up adding trans. So we're going to end up having 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so that's going to be our original hydrogen. So we've got one hydrogen here and one hydrogen here. Yeah, and so now we have the second step is D2 addition with palladium on carbon. So what I'll do is I'm just going to redraw this with a D that has a pink color just to make it easier to follow. And what we're going to do is you have to remember for this kind of reaction, the way that this is phrased is that it's implying that it wants you to take care to address stereochemistry. If it was me, I would make sure that you were aware that I was definitely involved in interested in stereochemistry. But we have to remember that because this is a planar molecule, we can have the addition of D2 either from the top or the addition of D2 from the bottom. So there are two different scenarios here. And it may make a difference, it may not, but you need to remember that that's always in the cards, that you can have D2 coming from two different directions. Okay, so, and you also have to remember that D2 addition, or just H2 addition, is going to be in a syn stereochemical manner, unlike the trans. So this is going to make a difference at the end of the day for how D is added. Okay, so what we can do is we can go ahead and draw the D's as if they had added in a syn from above. Let's go ahead and do that. So there's one D, there's a second D, and we're just going to say, okay, for this one, we had D2 add from above. Okay, and in this case, let's say we're actually looking at it from above, and our point of view is coming from this direction. So there's a little eyeball, and there's our point of view. So that means that we have, our ethyl going into the back. So there's our ethyl, and we have our H coming into the front. Same thing on the other end. We have our hydrogen in the back, and we have our ethyl in the front. Okay, so this ethyl right here is this ethyl, and this ethyl in the back is that ethyl. Okay, so that's one possibility, or we can have the second possibility of our D adding from below. That's also a possibility. So we'll redraw our carbon-carbon bond, and we'll have D's adding from below. So 3, so there's deuterium here, and let's go back and add ethyls and hydrogen. So one here and here. So again, let's keep this perspective. We're going to have an H towards us and ethyl away from us. So H towards us, ethyl away, and then hydrogen away, and then ethyl towards. Okay. So now let's think about what we're going to have in terms of stereochemistry. Can we actually draw a direct and easy comparison between these two? So I'm going to go ahead and try to do that. I'm just going to copy and paste this guy down below, and copy and paste the one from above. Okay. So these are the two different stereoisomers that you can form. And let's actually take this guy and pull him up like this. Okay, so it's obvious now if we were going to draw a mirror plane, we could draw our mirror plane kind of like this. Okay, and so now it looks like the deuteriums are matching up very well on the mirror. And if you look at the ethyl and the hydrogen on the left-hand side, so let's go ahead and draw just a partition so we can compare and contrast. We have one ethyl going backwards, one ethyl going backwards, one hydrogen going forwards, one hydrogen going forwards. And here on the right-hand side, we have one hydrogen going backwards, ethyl going forwards, ethyl going forwards. Okay, so it looks like right here what we have is a non-superimposable mirror image, or we have a mirror image at the very least. So you can try to rotate this in your head, redraw it, make sure. But if you actually took this guy and actually rotated it in three-dimensional space, let's do that. Let's rotate it on the x-axis. Okay, by 180. This is what you would end up getting. So you'd have our original molecule like this. We're going to rotate by 180, and we're going to have these, or the deuteriums, going down, and we'll have forward, away, away, and forward. So the ethyl was pointing down and away. It's going to end up pointing up and toward. And if the hydrogen was originally facing down and towards, it's going to be up and away. Same thing for the ethyl here, right there, and hydrogen right there. Okay, so now if we try to compare and contrast directly, and let's make this guy pink. If I try to pick this guy up and move it to the other molecule, it looks like we have an ethyl and a hydrogen on the left-hand side trying to superimpose, which is impossible, and we have a hydrogen that's facing back trying to superimpose with the ethyl. Okay, so let me actually break this up a little bit, make it easier to see. So I'm just going to rip off this end of the molecule and move it over. So if we move this over, you see how the blue hydrogen is facing away, just like the ethyl is facing away. So this is going to be non-superimposable if we try to put it on top of itself. Okay, so I try to put this back where it was. Okay, so now what we have is obviously non-superimposable mirror images. So if you want, you can figure out R and S for one, and once you do that, well, you can just switch it for the other. Okay, and that's that. So what you're going to get are these two stereoisomers, and they're going to be enantiomers of each other. Okay, and that's pretty much it for this problem. It's actually a little bit tricky at the very end in terms of stereochemistry, but the actual transformation isn't that difficult. Okay. All right, next question.